Hi there. Okay, well, I haven't posted a video in, I guess, in over a year. So this is where I'm at. I still have the same load that I had before. This is the capacitor bank. It's got these plates on it because I got shocked a couple times trying to put it back together. This is where the pickup is. Okay, let's go to the circuit. Okay, this is the circuit. Basic circuit. I'll take you from left to right. And by the way, I'm thinking about changing those tips for a MOSFET. Okay, we got the LED and all the rest of that, and the inductors, which are these three coils right here. Also, we have the control box, Radio Shack parts, basically. This is control. This is to turn it on. This, I don't know, it's kind of hard to see. But this right here is a neon bulb. And that's to absorb some of the back spikes. Right now, you see that the battery's sitting at, well, it's going down. Yeah, it's going down. About 320 some odd volts. Anyhow, so all that being said, I'll go ahead and start it up real quick. Couldn't resist a blue fan, sorry. And that centerpiece there is there, well, it's fun, but it's also a flywheel. Now, you can see the voltage increasing. You can see that the LEDs because there's a three-phase, I should have pointed this out before. From here you can see the stand that it's on is actually a three-phase servo, well, basically a servo motor of some sort. A stepper motor, excuse me. But it's one of the old-fashioned raw ones. Okay, let's see. Let me try and apply the load. That would be this over here. It's 15-watt bulb, 120. Kind of lights everything up. That's nice. And oh, sorry. As far as the schematic goes, there's a lot of variations you could have. Oh, you hear that? That's a bulb. That's after the bulb went down, and now it's loading. You can see the voltage is going down, and it's still climbing down. All I have to do is go back over here. Bink. You hear the speed change. Also, I had to go from using, let me turn it off for a second. I had to go from using aluminum tape to, another improvement, which is I can remove this whole piece, and now you can see the little dynamo underneath it. I had to use fiber tape because I had to chase after my magnets several times because they broke away. This keeps them in. They do it once it gets up to speed. It does actually expand. And also, I applied some foam tape, and that was to go ahead and compensate for, you know, the wobbling that I got before. Well, if you got any questions or anything, feel free. Oh, there's one more thing I want to show, because this is the whole part of it. I have here a coil And what it is, it's wound specifically for north. It's not wound just over and over and over and over again. It's wound where I come to the same coil, same spot, and I back it and wind it the other way. It's an old relay technique. Yes, and that's a relay coil in there. But this is a thing to understand about, because I've got the 3 coils here picking up power, but you could put other coils up there that aren't moving it, like I'm gonna do with this one. You see that LED right there? It's lit. See it go out. See it come back on. You could have a series of these, and it doesn't affect the performance. I know I've watched the voltage and see whether or not it's dropping, the speed. I guess the next thing to do is see if I can get this thing on a no-scope. And oh, that little blinking light, that's from another coil. And just for finality and grins and giggles, let's see if I've got enough. This is where the voltage is right now. Is it enough to turn on the light? Yep, I think so. So I guess the next thing is to do is to include a power management system, and see if how long it would take, see how far it would get if it was powering itself, or if it even powers itself. All right. Thank you for your time. Have a happy holiday.